Hi there, I'm Mina Lee, and this is our paper, A Design Space for Intelligent and Interactive Writing Assistants. This work was a large community collaboration with researchers from various disciplines, including HCI, NLP, information systems, and education. There have been a lot of new and renewed writing assistants introduced in the past few years, ranging from general-purpose systems like ChatGPT and Bing Chat to more specialized systems like Grammarly, WordTune, Pseudowrite, and ProWriting Aid. In fact, if you search for AI writing assistants, you can easily find hundreds of writing assistants. And that's just commercial systems. There are even more writing assistants and prototypes proposed in research communities. Communities like HCI, NLP, communication, computational social science, and economics study writing assistants with different perspectives and emphasis, such as user experience and interface design, model development and evaluation, AI-mediated communication, and societal and economic impact. With even more specific areas like creativity support and learning analytics, it has become quite difficult to stay up to date with work happening across communities. This splintering poses a significant challenge to have a holistic view and navigate the space of writing assistants. To address this challenge, we created a design space. A design space is a taxonomy that presents critical aspects of a design. It provides a shared vocabulary that can help us communicate with others. It can also provide support for understanding existing designs by exposing different design choices, as well as envisioning new design. To develop a design space, we first decided the scope to be intelligent, interactive, and writing assistants. Then, we identified 5 key aspects of writing assistants. The first 3 are user, technology, and interaction, where the user interacts with technology through an interface. Then, there is a specific writing task that affects part of the user, technology, and interaction, and a surrounding ecosystem in which all of these aspects exist, operate, and influence each other. With this scope and 5 aspects, we performed a systematic literature review to identify design considerations for writing assistants. First, we sampled papers that have variations of the word write in their titles from HCI and NLP venues. And then we filtered them based on the scope we defined earlier, which resulted in 115 papers. Then the authors split into 5 teams based on the aspects and developed codes by reviewing the papers. Concretely, each team distributed papers so that each paper was read by at least 2 members. They first independently read and coded papers, and then the team gathered to discuss and update the codes. We repeated this process until each team reviewed all papers under the final set of codes. What do the codes look like? Here is an example for the user aspect. For each aspect, we define dimensions as fundamental components of the aspect and codes as possible options for each dimension. In the final stage, all teams gathered to create the design space by combining all dimensions and codes and annotated the papers. This process resulted in a reasonable intercoder reliability for the annotated papers. As a result of the systematic literature review, we developed this design space for intelligent and interactive writing assistants. While we recognize that this design space may not be exhaustive or permanent, we believe it provides researchers and designers with a practical means for exploring, understanding, and comparing the diverse potential of writing assistants beyond their immediate fields. We cannot cover every dimension and code in this talk, but I'll briefly walk through a few dimensions and codes from each aspect with some concrete examples, and demonstrate how one can use the design space to generate ideas and critique existing designs. Let's first take a look at some dimensions in the interaction aspect. One of the fundamental components of interaction is the interface paradigm. Is it a text editor, chatbot, or something different? How is system-generated text or system output visually different from the user text? Is it in a different format? Is it located in a different location that's not the same as where the user text is? How is the system output triggered? Is it initiated by the user or the system? How does the user integrate the system output? Is it by selecting one of several suggestions or by being inspired by system outputs and indirectly using them? To make things more concrete, let's consider an existing system and annotate it based on the dimensions and codes. This is Co-Author, which is a system built in 2021, powered by GPT-3. Its interface is a basic text editor with one additional functionality. When a user presses the tab key, it shows a set of autocomplete suggestions. This is the example annotation for Co-Author. The interface paradigm is text editor. The AI-generated text is not visually different from user text. Users initiate the system output generation and integrate them through selection. With this annotation, it is clear that Co-Author is really just one instantiation of the design space among many possibilities. Also, one can use the design space to quickly identify relevant dimensions for a system and consider various alternatives when designing, understanding, and evaluating a system. Now, let's take a look at the user aspect. You might have realized that some dimensions may not be part of design considerations for a system. For instance, because Co-Author was built to explore human-AI collaborative writing without tailoring it for a specific user group, the dimensions like demographic profile or user capabilities were not considered during the design's process. On the other hand, we considered agency by making the UI user initiative and coherence by choosing the best performant model at the time. Before moving on to a different aspect, I'd like to point out the interconnected nature of these dimensions and codes across aspects. Suppose you're worried that using Co-Author will decrease users' sense of ownership over written artifacts. Maybe one way to mitigate such an outcome is to change how users integrate the system output. Instead of having users select one suggestion and directly inserting it to the current text, the UI can present inspirational system outputs at a different location, so that users need to be more deliberate and write out each and every word that goes into the final artifact. In this scenario, we can form a hypothesis that users feel more ownership and responsibility when they have to put more effort in integrating system outputs. Alternatively, we can start from the interaction aspect and reason about how that can affect users. For instance, you can make Co-Author system initiated and show users suggestions without requiring them to press the tab key. This could potentially increase users' efficiency by auto-completing more text, but it can come at the cost of decreasing users' agency. Based on this reasoning, we could envision a follow-up study for Co-Author to investigate this hypothesis. When the system initiates autocomplete suggestions, users' efficiency increases at the cost of their agency. We believe that the design space can help us recognize this interconnection and trade-offs and form interesting hypotheses based on them. Next, the technology aspect. The technology aspect can be an enabling factor, but also a limiting factor. Many writing assistants these days are built using foundation models and prompting, which allows quick and efficient prototyping while being able to handle a wide range of tasks without manually specifying them. On the other hand, based on our literature review, some technology dimensions are understudied. The x-axis of this plot is the dimensions, and the y-axis is the number of papers relevant to each dimension. In our literature review, we see some dimensions are understudied, such as external resources and scalability. With this information, we can envision that there would be more future writing assistants that utilize various external resources, such as web search, knowledge base, and are more cognizant of scalability-related issues, such as cost and latency. Speaking of current trends, we observe that most ecosystem dimensions are underrepresented in the current literature. The ecosystem aspect is interesting in that much of it is beyond the immediate control of writing assistant designers. Nevertheless, this aspect draws attention to how one might design in anticipation of ecosystems' influences. For example, co-author used a specific model instance of GPT-3, which has been deprecated by OpenAI. How does this loss of access affect the system's availability and subsequent user experience? When we switch or update the underlying model, how do we guarantee usability consistency? Would an interaction strategy or pattern that a user developed with one model work for another one? Lastly, let's take a look at the task aspect. The task aspect provides a nice way of delineating different parts of the writing process. Going back to our running example, co-author's data collection was in the context of creative writing, where we gave users a prompt to write a short story. In this setting, users were in the drafting stage and in the creative context. The purpose of the written artifact was to be narrative, where only a general direction was given to the users. Naturally, co-author's findings are very much grounded in this writing task. Then one can ask whether the findings from co-author would generalize to other writing tasks. Specifically, the work showed that many ideas generated by the system in the suggestions were accepted and reused by users in the subsequent writing. Would it still be the case if the users were in the revision stage and there were a lot of detailed requirements? Or what if the context was technical and purpose was descriptive? By thinking about alternative instantiations of the task aspect, one could contextualize findings from existing study and reason about their generalizability. In this talk, I quickly walk through our design space for intelligent and interactive writing assistants. There is so much more detail in the paper, including the definitions and examples for each and every dimension and code, so please check it out. We believe the design space can help you identify relevant dimensions and consider alternative designs, recognize interconnection and form hypotheses, identify understudied areas and envision new designs, and contextualize existing findings. Our design space is a living artifact, as it will evolve over time alongside the fields. We invite you to contribute to this artifact by adding new papers, annotations, and discussions to track future developments in this space. Thank you.